we're trying to figure out how many grams of precipitate are going to form out of this equation here, and also the excess reactants. We're given the grams of these compounds here. So let's figure out how many moles we are, because we have 1 mole plus this 1 mole equals 1 mole of this precipitate. So if we could figure out what the limiting reactant is, then we could figure out how many moles we have of that stuff. So for HgClO3 2, let's figure out what that would be. For Hg, it's just going to be 200.59. This is going to be the molar mass. Plus, there's going to be 2 of the chlorines. That's going to be 35.453. And then if we do 6 of the oxygens, that's 15.999. So the molar mass of all this is just going to be 367.49 grams per mole. So then we're going to also do that for the Na2S, which means that we have 2 of the Nas, 22.999, and one of these S's at 32.061. The molar mass is 78.059 grams per mole. Now let's multiply that by how many grams we have, because, well, that's going to be helpful, right? So we have 67.472 grams of this HgClO3 2 stuff. We're going to multiply that by, well, if we have the moles on top and the grams on the bottoms, then that could work. Okay, let's see what that would equal to in just a second. We're also going to do that for the Na2S. We got the 12.026 grams of the Na2S, multiplying that by the grams per mole stuff, so a mole, 78.059. And so now we'll figure out how many moles of these things we have. 67.472 divided by 367.49 gives us 0.18360. There's 5 sig figs here. Mole of the HgClO3 and then over here we would have 12.026 divided by 78.059, and so we get 0.15406 mole of the Na2S. So now we basically realize that this is the limiting reactant. So we're going to get just that same amount of moles of HgS. It's a 1-to-1 ratio. So we have 0.15406 moles of the final precipitate there, HgS. And we want to figure out what the molar mass of the HgS is. We got to look at the periodic table. It's just going to be 200.59 plus 32.061. That's going to be equal to 232.651. There's the sig figs there, grams per mole of the HgS. Okay, at this point, we should just be able to do essentially the same thing that we did over here. I believe we can just multiply this by that and the moles will cancel. So let's just go ahead and do times 232.651, I suppose. And then, so the final answer should have 5 sig figs, but it's just going to be, see, the grams of the precipitate is 35.843 grams. Okay, so that's the grams of the final precipitate. And then for the excess reactants, well, let's realize that we're going to have to subtract this many moles. So let's see how many moles are left over of this stuff. We got too much of that. So 0.1836 minus the 0.15406. So we know that left over, we've got 0.02954 mole of this stuff right here. Let's keep in mind that it's going to have 5 decimals, and therefore we have 4 significant figures there. So once we multiply this by the molar mass of all this, the moles are going to cancel, and we're going to be left with the grams of the excess reactants. So let's go ahead and just multiply that out. Find 367.49, and we should get 10 point, and there should be 4 sig figs, so 86 grams of the final excess reactants. So pretty good.